And now for something completely new, we're going to be doing exponential functions, and they look something like this. Now this is slightly different. We had x squared before, and those were like parabolas. And then we had polynomials with more degrees, and so we had these kind of movements like this. But y equals 2 to the x has a different shape. And so to show this, I'm going to do x here and 2 to the x here. So we're going to pick a few numbers here to plug in. And if I do 2 to the 0 power by plugging the 0 into x here, 2 to the 0 power, you may remember, is 1. And if we plug 1 into x here, that would be 2 to the 1, which is 2. And if we plug 2 in here, it would be 2 to the 2, which would be 4. And then if we put negative 1 in here, we have to remember that that negative 1 power is actually 1 over 2 to the 1. It takes this and moves it to the bottom of the fraction, which is really just 1/2. And so 2 to the negative 2 is 1 over 2 to the second, which is 1 over 4. So if we graph this, 1, 2, 1, 2, this point would be 0, 1, then be 1, 2, 2, 4. So it almost looks like a parabola on this side. It's going to grow that way. But going back, it'd be negative 1/2, which is like right here, and negative 1/4. So on the other side, it comes down, and it flattens out. Now, there's a special name for this, this right here. When it comes closer and closer to a line, but it never ever touches it, that's called an asymptote. When we do rational expressions, that's going to be more important. So just realize there's an asymptote there. There's a limit. This line will go forever and ever in this direction. You get closer and closer to 0, but it will never touch it. And so every exponential function will have this kind of form to it. So here is the form. Y equals a times b to the x power. Now in the example we just did, b would be 2, and a would just be that 1 in front that we didn't write, 1 times. Okay, so to kind of show how this works all together, I have a demonstration with GeoGebra here. On the left side I have a times b to the x power, and I'm going to adjust a and b to kind of show what would happen. For example, like when a is 2, we have the graph that I just graphed on the previous page. Now, if b gets larger and larger, what happens is it gets taller and taller. So it looks skinnier and skinnier. So let me bring this back to about 2. Now, if I am changing a, watch what happens. So now I changed a to 4, and you might notice that the y-intercept is now 4. If I slide it down to 3, the y-intercept is now 3. So I like to call a the starting point. Now, if I move a down to like -2, you'll notice it flipped over. And it's the same shape, it's just been reflected over, and it has a starting of around well, here it's -1.9. Okay, so let me bring this back here. So that's one thing we could write down on our notes. This right here is the y-intercept when it's in this form. If it's negative, it means it's flipped over and it's the y-intercept below. So going back to this, what happens if b gets smaller? Let's say that b goes below 1. You notice what happens. This has flipped over, and now it's starting to go down like this. And so when it's above 1, when b is like 4, it looks like it's going up, and this is called exponential growth. But when b is flipped around and b is less than 1, we call this decay, because the value is going down and down, further down. So this is some people say it's your growth factor. I'll say if b is greater than 1, we know then that it is growth. If b is less than 1, then it is decay. And growth looks like this when you graph it. Decay looks like this when we graph it. So using the y-intercept and whether it's growing or decaying, you should be able to draw a quick sketch of any exponential. Like, if I gave you this, you know two things. When you graph it, the y-intercept is going to be at 2. You also know it's going to be decaying. So it's going to come down like this. And similarly, if I give you another example like this, negative 3, 2 to the x, I know the y-intercept will be down at negative 3. And also, it's a growth, so normally it would be going up like this, but it's been flipped over because the a was negative. So it will be going down like this. So that is how you get the general shape of an exponential function.